Hello guys, welcome back to the Quantity Surveying workshop and to another video. Today's video is going to be beginning the series for measurement for a frame structure, and the theme for this video is we're going to be reading all the drawings that we're going to be needing to measure the substructural works for this frame structure. This is a one-story, or let's just say a duplex, and it is constructed using the framing method of construction. So I'm going to be using this as our drawing for this particular video, so stay tuned and let's get right into the video. So first we're going to be looking at the site plan. As you can see on the screen, normally when we're doing our site clearance, when we are not given the site plan, what we normally do is to get the area of the plan when we've added a certain amount of space, that's for workspace. But in this case we're not going to be doing that because they've given us our site plan. So if you look at the site development analysis, you can see some things written there. They say that the area of the site is 600 square meters, the built up area is 257.39 square meters, the unbuilt up area is 342.61 square meters. The information that you actually need is just the area of the site. So they say that the area of the site is 600 square meters. That is like about one plot of land. So we are not just going to be using that information, we have to measure it directly using the information given us on the drawing. So as you can see, the length of the plot is 29 meters, while the width of the plot is 20 meters. So if you do the math, it's like going to be getting like about 580 square meters of land. So maybe they approximated it to about 600 square meters. So using this drawing, we are going to be clearing the 580 square meters of land. We're going to be clearing the debris. So after doing that, the next thing we're going to be looking at is the building plan itself, starting from the ground floor. Look at the ground floor, and as you can see from the entrance porch, at the entrance you can see that there's a beam here. So maybe this beam might have an arc. So you can see there's a beam here for passage. Here there's another beam at this side for passage. That means there's an opening at the three corners. There's an opening here, an opening here, and an opening here, as you can see with the position of the beams. So once you get into the distance, you can see the lobby, right? So after you enter into the main building, you can see just in front you have your anteroom. Then within, just by the right towards the living room, you can see that there is a beam at this side. Now the purpose of this beam is to support the staircase, right? To support the staircase. So it means that there's going to be an opening in order for you to have access to your living room. So as you can see, this is your living room, and then it is a combination of both our living room and our dining in the same position. So after the dining, you can see that there is an entrance to the lobby, where you will not be getting access to your bedrooms. So let's just go back to the anteroom. As you can see, there is a door here to one bedroom. Maybe this could be a visitor's room or something, so because it is closer to the sitting room. So once you enter, you can see that this is the bedroom. There is a wardrobe here, and you can see the toilet. So nothing too serious here. So when you come out, right, this is the way you are going to be using to climb your staircase. So we are going to be climbing from here down to this side. So that's the essence of this arrow. So it means that from here you climb the stairs, sit on the landing, and then you move up. Now at this lobby, you are going to be having access to your bedrooms. You can see from the dining, we have access to our kitchen, right? From the kitchen, there is an exit door to the veranda, where there's another beam, a beam opening here, where you can come outside the building from the back. So inside the kitchen, there's a store. with what 150 block work. So this is very important. You have to take note of this, because in your substructural works, when you are doing your excavation for the trench, the size of the blocks matters too. You have to get your width of the trench. So this 150 block for the store. When you enter into this bedroom, you can see they use 150 block work for the internal wall of the toilet. Then when you enter into this bedroom, you can see that you've gotten the area of the bedroom. For the toilet was not lined with 150 block work. Instead, it was lined with 230 block work. So yeah, this is basically it for the ground floor. So after doing this, the next thing we're going to be putting in mind are the positions of our column base and our starter columns. So with that, we are now going to be going to the foundation drawing. So as you can see, this is the foundation drawing, which gives us the placement for our column base. So if you look at this, you can see that the dimensions of the foundation were not really given here, but with these dimensions that we have at the side, we can use it to determine what the length and the width of the foundation will be. However, they've already given us a detailed drawing for each of the different types of the column base we have in this drawing. Now if you look closely, you can see that there is a writing on each of the column base. We have BT2, BT3, it means base type. This BT means base type. If you look at this one here is base type 2. Here we have base type 3, base type 3, base type 2, base type 2, base type 2, base type 2, base type 1, base type 1, base type 1. This is base type 2. This is a base type 1. So base type 4. So from what I can see here, we have 5 different types of base of the column base here. It could be different in maybe in terms of their dimension, or in terms of the type of reinforcement that is placed inside that particular column base. So on that same column base, you can see there's another write-up there showing CT2, CT3, CT4 and the like. So this CT means the column type. So as you can see that on some parts of the drawing, it is thickened with black ink. The ink is thicker there, so that black ink shows the placement of your columns. So in every column basket, there will be at least one column. So as you can see at BT2, there's one column here, there's another column here, another column here. For BT4, there are 2 columns. So it means that the column basket is serving as a base for the support of these 2 columns. So the same thing applies to this, the same thing applies to this, the same thing applies to this. So you can see that there's CT1, there's column type 5, there's column type 6, all having different shape. Now if you look closely, this column type 1 is smaller than this column type 5, but they are both square in shape. Now if you look at this again, column type 5 and column type 6 are different shapes. Column type 5 is square in shape, column type 6 is rectangular. So now you can see that that is the reason why they had to differentiate the column bases and the column types, so that you can know that there are differences, they are not the same. So if you look by your right, you would see a section of your foundation trench through AA, which is this. It is cutting through the foundation trench, not the column base. You can see where the section is cutting through. So now they said that if you look at this, the depth of the foundation trench to the face of the column base, as the face of the column base is 1350. We are going to be having a 150 mm hardcore, and then 150 what oversight concrete. So as you can see, it's already stated here: 150 hardcore, 150 what concrete slab. So the size or the width of the foundation trench is what given as 675 So the thickness of the foundation trench of the concrete used to make this trench is 225. I just hope you can see this. The thickness is 225, and then just under the column footing you are going to be having a 50 blinding. So that is basically it for the section of this foundation trench. So the section just gives you more details as to what will be needed in order to excavate the trench, as well as to build up the foundation towards your oversight concrete level. So after doing this, we will now go into each of the base type properly. So this drawing gives us more details of our the base type or the column footings, showing us the length and width of the footings, as well as the placement of the reinforcement for the column baskets. So like I said previously, this particular foundation has 5 base types. There are different types. There are 5 different types of the column bases. Now we're going to be starting with base type 1. For base type 1, you can see that the length of this base type 1 is 1200. The width is 1200. The center point for the column base now will be the length divided by 2, the width divided by 2. That's why I can see 600 here, 600 here. If you add them together, to giving you 1200. So the same thing applies for the width. So it means that this type 1, the length and the width are equal. So length of 1200, width of 1200. So now let's look at the reinforcement details. So for the vertical bars, you can see we have 7Y12, that's 7 number of Y12 reinforcement. So this is bar 1. Bar 1 says 7 number of Y12 reinforcement at 175 center to center. It is the bottom bar. I hope you understand this. This B means bottom. It means that the reinforcement is lined on the bottom. So if you can look at this section, you can see that this reinforcement is placed under, just at the bottom of the concrete. So that is what it means. Similarly, for the horizontal bar, which is this, you can see it says 7Y12. That's 7 number of 12 reinforcement. This is bar 1, 175 center to center, bottom bar. So now you can see that the same information we have here for the reinforcement, both the vertical and the horizontal reinforcement are the same. Why? Because you know that the length is 1200 and the width is 1200. So it means that since we are using the same type of reinforcement and the same center to center spacing for both the length and the width, it means that the numbers are going to be the same. So both the vertical and the horizontal for bar type 1 is 7 in number. So we will now move to our base type 2. So for the base type 2, you can see the length is 1200, the width is 1200, the center is 600, the same thing as our base type 1. So now what could be the difference between base type 1 and base type 2, since they have the same dimension of 1200 length and 1200 width? So you will now look at the reinforcement details. In our reinforcement details for base type 1, they say that the vertical is what? 7 y12. But now in our base type 2, they say that the vertical is what? 8 y12. So the y12 reinforcement we're going to be having here will be what? 8 in number. That is why it is different from what? Base type 1. So that's why reading your drawing is very, very what? Important. So for base type 2, the vertical bar, which is bar mark 2, is 8 in number, using what? Y12, and as you can see, 150 center to center bottom bar. But in base type 1, they were using what? 175 center to what? Center. So now I hope you can see the what? Difference. The same thing applies to the what? Horizontal bar. So this is the horizontal bar. You can see the details. 8 y12, 150 was center to center bottom bar. Now you can see in the section, this is the horizontal bar lined like this, then the vertical bar will be lined across it. So it is in the bottom. That is why it states that it is what? The bottom bar. So the next thing we're going to be doing now is to check our base type 3. So now if you can see, base type 3 is quite different from base type 1 and base type 2. Why? Base type 3, the dimension is what? 1200 mm length by what? 2296 mm width. So the dimension is different from both base type 1 and what? Base type 2. So as you can see, this base type 3 has what? 2 columns. It's harboring what? 2 columns. Meanwhile, base type 1 and base type 2 only have what? 1 column. 1 column posts on it. So now you can see the difference. So now the placement for the columns now is 600 mm at the center on both sides. That is why you can see this 600 here, 600 here. The midpoint between this 600 on the width side and the center line of the length side, that midpoint is where the column post is going to what? Be lined. So that is the alignment of the what? Column. So now let's look at the what? Reinforcement details, starting with the what? Vertical bar. Now if you look at the vertical bar, this is bar mark what? 2. So you can now see that the number of this particular base type for the reinforcement is what? 12 in number. They are going to be using what? 12 mm reinforcement, and look at the spacing. It is at what? 200 center to center. And look at this, the reinforcement is both at the top and at the what? Bottom. Similarly, if you look at the what? Horizontal bar, which is this one, the horizontal bar is longer than the what? Vertical bar, because the length and the width of the column base, they are what? Different. So now let's look at the reinforcement for the horizontal bar. This is the reinforcement for the horizontal bar, and look at the details. This is 6 y12, this bar mark 3, 200 center to center, top and bottom. Now why is this 6 in number? You know that normally if you are not given these details, to find the number of this reinforcement bar at the width, all you need to do is this: find the length of the column base. If the reinforcement is horizontal, you are going to be using the vertical dimension of the column base. If the reinforcement is vertical, you are going to be using the horizontal dimension of the column base in order to find the number of reinforcement you are going to be needing for that column base. So now, for example, now we're looking for the number of reinforcement that we're going to be needing for the horizontal bar. So all I will just do is to get the vertical dimension, which is the length, which is 1200, right? We will now minus concrete cover. Maybe you can assume that the concrete cover is 25 on one side, or 30 on one side, or 50 mm on one side. So let's just assume that the concrete cover is what, 25 mm. So if I minus 25 here, 25 here, that's 50. So 1200 minus what, 50, that will give me what, 150 mm. So since they say that the center to center spacing for this horizontal bar is 200 center to center, so 150 divided by 200 will give you the number of bar for this what, horizontal reinforcement. So in our structural information, they said that the concrete cover that we're going to be using for our column base is what, 50 mm. So now that you know that 1200 is the length, right? This is just a practical example to determine if this number that they gave us here is correct. So we know that the length, we're trying to find the number for the horizontal bar. So the horizontal bar, we're going to be using the what, vertical dimension, which is what, 1200. So 1200 minus, they say that the concrete cover for the column basis is what, 50 mm. So if we minus 50 mm from this side and from this side, which will give us what, so that's 50 mm times 2, that would be what, 100 mm. So when we minus 100 from 1200, we're going to be having what, 1100. So you're not going to be dividing that dimension by what, center to center spacing. So 1100 divided by what, 200 center to center spacing that they're giving us there is going to give us what, 5.5 number. So 5.5 approximately is what, 6 in number. So now you can see how they got this 6 number of reinforcement for the base type 3. So now you can see that it says top and bottom reinforcement. So it means that the reinforcement for the column basket for base type 3 on the bottom, we are also going to be seeing it on the top, as you can see in this section. So you can see what we have on the bottom is the same thing as what we have on the top. So so now you can see the difference between base type 1, base type 2, and what, base type 3. So the next base type is what, base type 4. Now if you look at this carefully, you can see that base type 3 and base type 4 look similar. They're rectangular in shape. They are both having or harboring what, 2 columns. So what could be the difference between this base type 3 and the base type 4? So now let's look at the length first. So you can see that the length for base type 4 is 1200, the same as base type 2, the same as base type 3. Now let's look at the width. The width for base type 4 is what, 2378. As you can see, is different from what, the width of what, base type 3, which was 2296. So now you can see that the dimension for base type 4 and base type 3 are quite different. So now let's look at the what, reinforcement. So now for the vertical bars, right, the vertical bar states that what, we are going to be using what, 14 number of what, Y12 at 175 center to what, center, top and bottom bar. So I told you how to measure or how to determine the number of this reinforcement in the column basis, right? So what you just need to do now is to rewind and listen to it again and try it out. So in our structural details, they say that the concrete cover is what, 50 mm for one side. So 50 times 2 is what, 100. So just minus it from the distance and you can get your what, the number. As you can see, the vertical bar says 14 number of what, Y12 at 175 center to center, top and bottom bar, while the horizontal bar states 7 number of Y12 at 175 center to center, top and what, bottom bar. So as you can see, there's a reinforcement basket or a column basket on the bottom and then on the top. Now if you've gone to sites and you've seen them constructing the reinforcement, you can see that there's a space between the top and the bottom reinforcement. There's another reinforcement that actually holds, that supports the top reinforcement to the bottom reinforcement. It's called a horse bench. You can Google it to see what it looks like. So this horse bench is what is going to be used to give it that kind of like form, or to give it support, because this reinforcement cannot just be placed in the concrete like that. It's going to sink, so there has to be something that can give it what? Support. So that thing that gives it support is called what? A horse bench. Is another reinforcement. So that particular type of reinforcement is called a horse bench. Its purpose is just to give reinforcement placing like this a kind of what? Support. So after this, we are now going to be going to our what? Base type 5. So now if you look at our base type 5, our base type 5 is completely different from what our base type 1 down towards 4. The length of our base type 5 is what? 1400. The width is what? 1400. So since we know our length and our width, we can now determine the number, but it is already given in our what? Description, or in our detailing. So for the vertical bar, which is this one, we will now see that the details is 8y12. This is bar mark 4. So 8y12 at 175 center to what? Center bottom bar. So it means that the y12 that we're going to be using for this vertical bar will be what? 8 in number, at a spacing of 175 center to what? Center. So if we look at the horizontal bar, the detail says 8y12 bar mark 4 175 center to center bottom bar, the same as the what? Vertical bars. Why? I've already explained this before, because you can see the length and the width are the same, and they are using the same what? Center to center spacing. That is why both the vertical and the horizontal bar are what? 8 in what? Number. So like you can see, bottom bar, and if you check this section, the reinforcements for the column basket is only at the what? Bottom. I hope this is what? Easy to understand. Now since we've digressed on the numbers and the detailing of the reinforcement for the column basket, how do we now determine the length of this reinforcement? So this is just how you do it. To determine the length of reinforcement, it is just simple, because they have given you the drawing. It's not something that you now have to use your initiative or your knowledge from sites to now be measuring. All the drawings have already been what? Given. Now you can see, let me just use base type 1 as an example. Base type 1, the reinforcement, let me just use the horizontal reinforcement. Now if you can see in this base type 1, the horizontal reinforcement, there is a spacing right between the edges of the what? Column bases. That spacing is called your what? Concrete cover. And I've told you that in our specifications here, they've told us that the concrete cover for the column base should be what? 50 mm. So it means that there is a spacing of 50 mm before you see the start of the reinforcement. Just like you can see in this section, there's a spacing of what? 50 mm just before the reinforcement starts. And at the other side, there's another spacing of 50 mm just before the reinforcement ends. So with that, since you know the length of the column base as 1200, you can now minus the concrete cover from both sides. It will give you the what? Length of this reinforcement. Now mind you, the additional reinforcement is bent at the top, right? As you can see in this section, if you've gone to site and you've seen when they are bending reinforcement for column base, you will understand what I'm talking about. So I'm not going to be leaving an addition for this bend at the two sides of the reinforcement. So that's basically how you measure for the reinforcement of the what? Column basket. So the same thing applies for both the horizontal reinforcement and the what? Vertical reinforcement. So that is that for the reading of the what of the column basis for this particular drawing. So the next thing now we're going to be treating is to determine how to go about the measurement of our starter columns. Now, what do I mean about starter columns? Starter columns are that reinforcement that are attached to the column baskets, right, to give it support. So this is where the columns that you see in the buildings are then now added to. So let me just bring in another drawing so that you can understand what I'm saying. Now, if you look at this drawing, right, this drawing shows the placement for the starter columns from the substructure down to the first floor. You know, this is the ground, this is the foundation work, this is the ground floor, this is the first floor. So now our concentration should be on the foundation, because we want to measure the substructure of this drawing. So now if you look at this thick L shape here, right, you see that what we have here is the same thing we have in the section of our column base. Now please take a look at this. You see this thick line, this is reinforcement. You can see that it is the same thing we have in the section for our column base details, right? So I'm going to be explaining it better with this drawing. So now if you look at this starter column is bent in such a way that it will be attached to the column basket. So now let's just say that this is, let's say, 300 mm. I'm making an assumption. So let's just assume that from here to here is 300 mm. So now if you look at this starter bar, there's a reason why it is called starter bar. You will see what I'm talking about. Now you can see that this thick line goes up, passes through the oversized concrete, and then there's an extra of 750 mm just on top the oversized concrete. The purpose of this extra is so that the column for the ground floor, after the iron bender has already created the reinforcement for the column. The purpose of this extra is that to give support to the reinforcement. You can see another reinforcement now at the side is coming from here and then going up, similarly to how we had in our foundation. So if it is like 5 floors, 6 floors, this is the approach that they use to do the reinforcement for the column. There must be extra for the attachment of the reinforcement for the next floor. I hope you understand. Now you see that because of there's the drawing that we're using is just 1 floor. You see that it ended here. It did not go up again, just like you can see in the previous one. Let me come again. The ground floor, you can see the reinforcement passes through the slab, and then there's an extra of 750 mm on top. This 750 mm acts as a support for this other reinforcement coming like this. I hope you can see it. So that is just the basic principle. So now with the dimensions that they're giving us here, we can easily measure for the reinforcement from the substructure down to the first floor. So all you need to do now is to determine what is the dimension from here to here and get the dimension from here to here, then the dimension from here to here. It's as simple as that. So if you do not understand what we've been doing here, when we begin the measurements properly, you are going to be understanding it better. So now you can see that at the side of the drawing we have our section. So this section for section 1-1 is the section here for the ground floor and for the foundation, right? So now you can see that this section harbors the links or the stirrups for the column reinforcements. So you can see that the section for the column harbors what the links and the what stirrups, and this section 1 which is this, and it shows us the shape of the what column post, which is rectangular in shape. As you can see, this is the rectangular distance. The length of the column is what 230, and the width is what 230 mm. So you can see the dimensions are already what given here. So now if you look at this drawing, right, starting from the what substructure, you can see that there's a line here, a horizontal line, and on top this horizontal line they say 4y1601. What this simply means is that the type of reinforcement that we're going to be having for this starter column is what y16, and there will be what 4 in number, just as you can see these dots from this section, right? You can see there are 4 in number, 1 2 3 4. That is what it's simply telling you, 4y16. So the type of reinforcement using to make this starter column is what y16, and there will be what 4 in number. Similarly, the links or the what stirrups, that line says y10 00, that's bar mark 0, links at 200 what center towards center spacing. So now just on the line you can see there's a 7 there, so it means that the number of these links is what 7 in number. That's what it simply means. The number of the links that will be lined from here to here is what 7 in number at 200 what center to center spacing. So the same thing that we did here is the same thing we're going to be doing in the word superstructure, but our main focus is the substructure because that is what we want to measure. If you can see the superstructure, the column post from here goes up. It says 4y16, the same way thing you can see here. There are 4 vertical columns in number, and then the links from here to here is where we're going to be seeing our links, from here to here. So now the links will be what 16y10 at 200 what center to center spacing. So the y10 reinforcement I'm going to be using for the links is what 16 in number. So last but not the least, the last one we're going to be looking is just a section of the drawing. So now this section we're going to be looking at the word substructure. You can see the finishing, they say floor tap finish as what specified. So whatever the specification for our finish, for our floor finishing in our specification drawing, that is what we're going to be using here. The second one says 50 mm thick cement sand screeded what bed. So this 50 mm thick is the bedding for the what tile finish, as the mortar that they use towards fasten the tiles or the floor finish, whatever it is, to the what overside concrete. So the next is what 150 mm thick overside concrete ground floor. So the next is what 300 mm thick compacted what stone hardcore. So the hardcore will be what 300 mm what thick. And last but not the least, 150 mm thick compacted laterite earth fill, ran in layers after what watering. So we are going to be needing this piece of information when we are what measuring for our what substructure. So with this, we've totally analyzed or read the drawings needed for the substructure measurements for this particular what drawing. So we've come to the end of today's video, guys. I hope you derived adequate knowledge from it. Please, if you did, do not forget to like, share and subscribe to this channel because it helps the channel grow. Thank you, and we'll see you in the next video.